for chapter 2. Starting out with number 1, we want to write a conditional statement in if-then form for the statement, all fish have fins and gills. And so we want to change that to if-then, so we want to define what we're talking about, which is an animal called a fish. And so if an animal is a fish, then it should have fins and gills. So if an animal is a fish, then it has fins and gills. Alright, so then number 2 here, in the following conditional statement, identify the hypothesis and conclusion. Okay, so we got if an animal is a monkey, then it has a tail. If we remember correctly, the if portion of an if-then statement is the hypothesis, the then is the conclusion. So therefore, the if part, an animal is a monkey, is the hypothesis. The then portion, it has a tail, would be the conclusion. So now we're going to move on to the next group, which all deal with these two statements, the P statement, which is today is Saturday, and the Q statement, which is I will watch college football. And we want to use those statements to create the statements asked for. And for the first one, it's a conditional, which remember, a conditional is in the form of if P, then Q. So we want to start with the P statement, end with the Q after then. So that's going to give us, if today is Saturday, then I will watch college football. All right. Next statement, simple enough, it just tells us Q to P. So if Q, then P. So we're taking this statement we just wrote in number 3, and we're flipping it around so that the Q's in front, the P's in back. So it becomes, if I watch college football, then today is Saturday. All right, number 5, it's got the little wavy line in front of the Q. Remember that little wavy line, or squiggle, whatever you want to call it, is the symbol for negation, or making it negative, or putting a not into the statement. And we're just talking about the Q. So I will watch college football, we want to put a not statement into that and make it a negative statement. So I will not watch college football is what we end up with there. And next up is the contrapositive. And for the contrapositive, remember that is the negation of the converse, or in other words, we take the conditional, we switch P and Q, and then we put nots into it. So basically this Q then P, that would be the converse. If I watch college football, then today is Saturday. So I'm going to take that and make it into negative statements. So if I do not watch college football, then today is not Saturday. Then 7, we got P and Q with a double arrow in there. Remember, the double arrow indicates it's a biconditional, which means that it goes both directions, and therefore we put the if in the middle, if and only if in the middle. So that's what defines it as a biconditional, having if and only if. So we take the P statement, today is Saturday, if and only if, then the Q statement, I watch college football. And then 8 has the negation symbol in front of P to the negation symbol in front of Q, or if not P, then not Q. Right, so we're just taking the inverse of the conditional statement. So taking this conditional statement in PQ form and putting nots into it, so that if today is not Saturday, then I will not watch college football. So that's all that deal with those P and Qs. Next up, number 9 wants us to state whether the argument's valid according to the law of detachment. And we want to explain why or not. Why not? So it says Sarah knows that all sophomores take driver's education in her school. Hank takes driver's education, so Hank is a sophomore. Well, this would be an invalid statement because just the fact that Hank is a sophomore, or does not, or just the fact that Hank takes driver's education does not mean that he has to be a sophomore. The statement does not tell us that only sophomores take driver's ed. And really and truly, it doesn't even tell us if Hank goes to Sarah's school. So we can say it's invalid because we don't know if Hank goes to Sarah's school or if only sophomores take driver's ed. You might be able to come up with some other reasons why that would not be valid. Now, if, on the other hand, if it had said that Sarah knows that all sophomores take driver's education in her school, and said that Hank is a sophomore in Sarah's school, then we could have made the conclusion that Hank was taking driver's ed. Alright, so moving on to the next one, number 10. Write a conditional statement that can be made from the following true statements using the law of syllogism. Remember, law of syllogism just means we take two statements that have something in common. We get rid of what they have in common and put the leftovers together. So if I look here, if a plant is the largest plant on earth, then the plant is a Sierra redwood tree. If a plant is a Sierra redwood tree, then the plant can weigh 1,800,000 kilograms. So in this case, if we look for what they have in common, both statements talk about a Sierra redwood tree. So they both have that in common, which means that we get rid of those parts and we put together what they don't have in common. If a plant is the largest plant on earth, then the plant can weigh 1,800,000 kilograms. So next up is solving some algebra problems, and it wants us to give a reason for each step, reason that allows us to make each step possible. So we start off here. We got 3q plus 9 equals 27. Okay, and the reason for that is it's given. That's what they gave us to start off with. And then we're just going through the process of solving. So I'm going to move the 9 over by subtracting, which is going to give me 3q equals 18. The reason we got to that step was the subtraction property of equality. And then from there we need to divide both sides by the 3. So 18 divided by 3 is going to leave us with x equals 6. So the property that we used there was the division property. Of equality. Okay, so the next one, a little more complicated. All right, so we're going to start off with this equation. 3 times 4v minus 1 minus 8v equals 17. And we know that is given. And then we're going to take that 3 and we're going to distribute it to the 4v minus 1. So 12v minus 3 minus 8v equals 17. That's the distributive property. Okay, sorry that I was interrupted there, so you might notice some things have changed on the screen, but we're right here where we left off. The distributive property of equality. That's what we did there to distribute the 3. Then we're going to combine the 12v and the 8v, so that's going to give us 4v minus 3 equals 17. And since we're just combining on one side, that's just simplifying. If I could write today. So let's simplify. Then we're I'll move that 3 over by addition, so that'll give us 4v equals 20. Addition property of equality. And then lastly, divide both sides by 4, give us v equals 5, and that is the division property of equality. Alright, number 13, we're going to solve for the variable using the given information that segment PQ is congruent to segment QR, and segment QR is congruent to segment RS. So when we look, if they're both congruent to QR, PQ and RS should be congruent to each other. And if they're congruent to each other, then that means that we can set those segment lengths equal. So 4x minus 6 equals 2x plus 2. And then solve from there, subtract 2x. So 2x minus 6 equals 2, add the 6. It's going to give us 2x equals 8, and divide by 2, so our x equals 4. And then number 14, got a proof there. Given that wy equals xz, prove that wx equals yz. So start with the given, wy equals xz. Good. Then we're going to go from there and explain what wy and xz are, because when we look, wy is the big segment and xz is a big segment, where wx is part of wy and yz is part of xz. So we're going to try to bring those parts in by explaining what wy and xz are. So wy is made up of wx plus xy, and xz is made up of xy plus yz, which is the segment addition postulate. And from there, since wy equals xz, and wy is equal to wx plus xy, and xz is equal to xy plus yz, now we can jump to say that wx plus xy is equal to xy plus yz. That's substitution. Property of equality. And now once we can substitute those, because wy is the same as wx plus xy, and xz is the same thing as xy plus yz. Now if we look there, on both sides of the equal sign we have xy, and so if we remove xy from both sides, because we can remove the same thing from both sides, and removing it from that side is called subtraction, right? So subtraction property of equality. Alright, so then 15 here, complete the statements given that the measure of angle AQF equals 90 degrees. So AQF is 90 degrees, and it's right here. We want to know the measure of CQD, which is straight across from it, or it's a vertical angle, and we know that angles straight across from each other that are vertical angles are congruent. So since AQF is 90 degrees, then CQD should be 90 degrees. Then 16 tells us if the measure of BQD, so BQD, if that's 113 degrees, then what's the measure of BQC, or EQF, I mean? what we have to recognize is EQF is a vertical angle with BQC. So we can figure out what BQC is, then we know what FQE is. And so if CQD is 90, then this is going to be 113 minus 90, or 23 degrees for BQC. So EQF should be 23 degrees as well. And then 17, we want to know what the measure of angle AQF plus the measure of angle EQF plus the measure of BQA is. Which, when we put those down there, we recognize that all three go together to make a straight line, angle BQE. And so since that's a straight line, that's 180 degrees. And so then we got this proof here. I've already went ahead and filled it in for time's sake here. So you got 18's asking for a given. And so we look, there's three givens there, AD equals 8, BC equals 8, and segment BC is congruent to segment CD, which BC equals 8 is right here, so we can go ahead and label that as a given. And BC is congruent to CD is right here, so 22 would be a given as well, which leaves AD equals 8, the only one that can go in 18. And so if AD equals 8 and BC equals 8, by the transitive property of equality, since they both equal 8, they should equal each other, so AD equals BC. And then they give us the definition of congruent segments, and we use that rule anytime that we want to switch from between congruent or equals. So we're equals here, so we want to be congruent, so we switch it to segment AD is congruent to segment BC. And then we got BC is congruent to CD. So notice AD is congruent to BC, BC is congruent to CD. So since they're both congruent to BC, AD should be congruent to CD, and that's the transitive property of congruence. And lastly here, 24 gives us that angle 5 is congruent to angle 6. So these two in the center here are congruent to each other. We want to prove that the ones on the outside, 4 and 7, are congruent. So here we got that angle 5 is congruent to angle 6, that's given. And so if those two are congruent, then we also recognize that when we look at 6 and 7, we can see that those are vertical angles, and by the vertical angle theorem, 6 and 7 should be congruent. So then, since 5 is congruent to 6, 6 is congruent to 7, we can say that 5 and 7 are congruent to each other, because they're both congruent to 6. That's the transitive property of congruence. And then we bring in that 5 is going to be congruent to 4, because those are a vertical angle. We can tell by looking at the picture there. So the vertical angle theorem tells us that angle 5 is congruent to angle 4. And now we look, angle 5 is congruent to 7, 5 is congruent to 4. So since 4 and 7 are both congruent to 5, they should be congruent to each other. So angle 4 is congruent to angle 7 by the transitive property of congruence. So that wraps up the review. So hope you study hard and do well on this one. See you at the test.